Welcome to the second lecture of the Programming Languages course. The title of today's lecture is How to Design Programs. You may have some experiences in writing code, writing programs, but have you ever thought about designing programs? That's the first thing to do. And I hope you learn what to do, what that means, and you can design programs from now on. So the next two slides you already saw on Monday. Our lecture is going to have a pattern. In the beginning, I'm going to emphasize important stuff from the previous lecture, and we dive into the new material for today. On Monday, we talked about how we are going to learn programming languages in this course for this semester. Programming language concepts can be taught in many ways, but in this course, we are gonna use two ways. By using the Scala programming language and by implementing interpreters. Interpreters are really important, and I'm going to tell that in the next slide. But before that, there are several approaches to study programming languages. A survey approach is to learn many programming languages very lightweight. Some ways are learning one specific programming language like C or Java thoroughly for the entire semester. In this course, we'd like to define several languages, very simple languages, but touch on important concepts in programming languages by implementing interpreters. What does that mean? You're going to see that over the lectures. And you are supposed to implement interpreters in Scala. Okay? So then what are interpreters and compilers? Even though I explained that on Monday, there were several questions and I wanted to emphasize that one more time. An interpreter takes a program as an input and produces a result. I think that's pretty much what you've expected. You provide a program and an interpreter runs it and give you a result back, just like a calculator. So it's really good for understanding program behavior because you write some code and run it, it's going to give you the result. And it's pretty easy to implement that. And a compiler takes a program and produces another program. Are you kidding? You want to run a program and get the result, but it produces another program. What does that mean? Another program which is different in the sense that usually the input program is written in a source language and the resulting program is written in a target language. For example, when you compile a C program by using GCC or some other compilers, then the source program, the input program is written in C and it produces some, say, A.out, some object code. When you compile a Java program written in Java and compile it, it produces a Java bytecode, .class file, like that. Then what are they? Why do we want to have different languages? Because these source level programming languages, they are good for people, meaning that it's more like closer to mathematical notation or pseudocode algorithms like that. But if you want to try to understand the programs multiple times, then you need to read every character and do the same thing over and over again, just like interpreter. So interpreter, you only need to read one line each and run it. It's easy, but it takes time. If you want to run the code only once, then interpreter works well. But if you want to run the same code like multiple times, 100 times or even more, then it's slow. In that case, you want to have a compiler because the source level programs can be compiled down to more efficient code. They are more closer to machine level assembly code so that programs can be easily understood by computers, not by people. And while doing this compilation, the compiler can check some errors. Like, oh, you are trying to add a number and a string, you bad. We want to reject that code, kind of thing. In an interpreter, it doesn't check. While you're running that wrong code, you're going to get a runtime error. But with a compiler, you are not going to run it because the compiler will tell you. And because the compiler understands every single line altogether and produces another program, it can optimize the source level program to this target level program. Then when you run this compiled version, it's gonna be way faster. Okay, so that's good things about compilers. Exercise number 1 is available from Piazza. As I said on Monday, this used to be homework number 1. And we want you to do it so that you can be familiarized with this Scala programming language. If you don't do that today or this week, the remaining semester for this course is going to be disaster. Okay, so please try to write code in Scala so that you are well equipped for project 1 later. Programming languages. This code is from this kind of textbook, but reference, I would say, Programming Languages Application and Interpretation, PLAI. Sriram, who's the author of the book, said, virtually every language consists of a peculiar syntax, some behavior associated with each syntax, numerous useful libraries, and a collection of idioms that programmers of that language use. So, yeah, the main reason that the Java programming language is famous is that it has lots of libraries. And every language has different style of programming. We can discuss that later, but the main point for today is syntax and semantics. You're gonna see that in a minute. Syntax. It describes how programs look like, how you type keyboards so that you can write code. So syntax is how it looks like, this outfit, okay, visual outfit. And there are 2 kinds of syntax, concrete syntax and abstract syntax. Concrete syntax meaning how you write code. For example, let's say I'd like to add 2 numbers, which are 3 and 4. So if you want to add 2 numbers 3 and 4, you may want to write 3 plus 4 like this mathematics. It's called infix. Or you may want to say, numbers are more important than the operator. So write down the arguments, the numbers, and then the operator. Or you may want to say, operator is more important. So plus and numbers. This is called postfix because operator comes at the end. This is called prefix because the operator comes in front. This is called infix because it's in the middle. So they're all different. You may want to say 3 plus 4. You may want to say plus 3, 4. They are slightly different, but they mean the same thing. What? Addition of 2 numbers. Addition of 2 numbers that are 3 and 4. Okay? So whether you want to say some expression and then semicolon, or you may want to say curly braces, they are visual things. They do not affect the meaning of the code. That's called concrete syntax. And what that actually represents, that's abstract syntax. And semantics, when you write 3 plus 4, what does that mean? That's what we call semantics. Syntax and semantics, how you write it and what you mean by that. How to explain semantics? There are 2 kinds of ways. The first one is mathematical, and the second one is interpreter semantics. And in mathematical techniques, there are, again, several ways. Most obvious ways are denotational semantics, operational semantics, and axiomatic semantics. wherever they are. If you are interested in them, I strongly recommend you to take CS520. And in this course, we are going to learn operational semantics. Don't worry, you are going to do that a lot during this semester. And the second thing is implementing interpreter. To explain a language, write an interpreter for it. That's another way for us to learn language semantics. So again, a programming language is defined by how it looks like, syntax, and what that means, semantics. And how do you describe syntax? By a grammar. And how do you describe semantics? By rules. And we're going to see concrete examples in a minute. Because this is one of the important concepts today, I will repeat what I just said in Korean and move on. 프로그래밍 언어를 정의한다고 하면 그게 C든지 자바든지 자바스크립트, 파이썬, 그게 뭐든지 간에 여러분 그 코드 어떻게 쓸 거예요? 함수 선언할 때는 키워드, DEF 뭐 이런 거 정하는 거 있죠. 그게 문법이에요. 이 문법을 가지고 프로그램을 어떻게 쓰는지를 정할 거고요. 그렇게 쓰면 그게 무슨 소린데? 그게 시멘틱스예요. 그거는 규칙으로 정할 거예요. 우리가 이제 하나씩 볼 겁니다. Let's see how we can define syntax. Because you are familiar with mathematics, let's begin with arithmetic expressions. How would you define the syntax of arithmetic expressions? By defining its grammar. A grammar of expressions is usually written in a form called BNF, Backus-Naur form. So Backus and Naur, they are two different people, and they happen to design or devise this form independently. Yeah, that's funny. How do we define a grammar of arithmetic expressions? Let's see. These quoted, 따옴표로 한 quoted things are terminals, meaning you can type that in your keyboard. Open. Now I'm going to call open parenthesis open. And I'm going to call close parenthesis close. And there's another quoted plus. You can write them on your keyboard, right? Open something plus another close. Or number 1, number 42, number 17 or more. So these are terminals, and these unquoted things are non-terminals, meaning that num for numbers. A number is either 1, 42, 17, or something like that. An expression, there are 3 ways to construct an expression. So we call them meta variable, and that defines a set. So let's see. An expression is a set of arithmetic expressions. And there are 3 ways to make one expression. The first way is a number. When you write a number, it's an expression. And when you write open and some expression and minus and another expression and close, that's another expression called subtraction. When you do this thingy, it's going to be an addition expression. Do you see that? One more time. These meta variables expr defines a set of expressions. And these terminals define an element in the set. Let's see. So num is a set of numbers. The set num is the set of all numbers. So if you want to make an example of num, just pick one element from that. So 2 is a number. 298 is a number. So they are elements of the set called number. Expression. To make an example expression, choose one case in the grammar. Pick one example for each meta variable. Combine the examples with literal text. Literal text meaning terminal. Right? And what I just said before, expr and num, they are meta variable, right? And they are also called non-terminals. Then, what does that mean? To make an example expression, choose one case in the grammar, pick an example for each meta variable, combine the examples with literal text. Let's see what that means using examples. Here's one example. How would you make it? How would you make an expression? Choose one case in the grammar. Yeah, right. There are 3 ways to make one expression. 3 ways. I'm going to pick the most simplest way, which is a number. How can you make it? So choose one case in the grammar, num, and then pick an example for each meta variable. Oh, there's only one meta variable. So pick one element, number 7. Combine the examples with literal text. Oh, there's nothing to combine. Make 7. That's an expression. Meaning that this is 7, okay. This terminal, this literal text is 7, which is an element of a set called num, which is a subset of expr, right? Do you see that? So these non-terminals, meta variables, represent sets of literal texts or expressions. Let's see. To make another example expert, choose one case in the grammar. Again, there are 3 cases, and now we picked the first case, addition, right? It's gonna open one expression plus second expression close. That's for addition. Oh yeah, we know that. Pick an example for each meta variable. Pick an example for each meta variable, meaning how many meta variables do we have in the first case? Do you see it? 1, 2. Okay. So we picked the first case. We are gonna pick an example for each meta variable. So this one is gonna be what? Expression is the subset of num, which is the easiest way. So we are gonna pick 8 for this. What about the other meta variable? Oh yeah, this one could be different, but because we are lazy or efficient, we are gonna use 8 for that one too. Then combine the examples with literal text. Oh, okay. So this is gonna be open one expression, which is 8. So 8 plus another expression, which is again 8 close. Yeah, we are done. We combined the examples with literal text and we created open A plus A close, which is an expression, right? Very good. So let's see another example. Oh, these notes remain just there. That's ugly, but yeah. Let's see the second case. To make an example expert, choose one case in the grammar. We picked the second case, subtraction. Pick an example for each meta variable. How many meta variables do we have? 1, 2. Pick one. This time let's be a little bit more complex. Okay, the first one, what do you want? I want this thingy. Oh yeah, because it's an expression. So I'm gonna say it's gonna be 8 plus 8 close. What about the, pick an example for each meta variable. What about the second one? Second one, what do you want? I want, open 42. That's the ultimate answer to the universe if you've watched or read Hitchhiker's Guide to the Galaxy. 42 plus 7 close. This is an expression. How did you know that? Because, let's see, because this is open 42, which is a number, plus 7, which is another number, which is an expression, close. That's an expression. Okay, then what do we have? We have, open, the first expression is 8 plus 8 minus the second expression is 42 plus 7 and close. Combine the examples with literal text and what do we have? Open, 8 plus 8 close minus open 42 plus 7 close. This is an expression. So later, as a quiz or easy problem in your midterm exam, you may have some grammar for some language, say lang. That's the meta variable. And we may have several ways to create elements of this set lang. And we may give you the syntax for that, and you may need to make some examples out of that. So let's look at this example. Ice cream. This is a non-terminal ice cream. So that's surrounded by these angle brackets. Ice cream, in this store, we have 1, 2, 3, 4, 5 ways to make an ice cream. So there's sugar cone, and there is waffle cone, and it claims that just waffle cone is an ice cream. But you may not want that, right? We'd like to have, say, scoop of some flavor on ice cream. What's going to be the flavor? A flavor is going to be either vanilla or lettuce. Ooh. And we can put cherry on it. We can put sprinkles on it. So this is a way to make an ice cream. And we may want to ask questions like, how do you want to make an ice cream? Or we may want to ask questions like sprinkles. Is it an ice cream or not? We may want to say vanilla. Is it an ice cream or not? Or we want to say scoop of, what do you want? Vanilla on waffle cone. Is it an ice cream? Yeah. Why? Because there is a way to make it. Scoop of flavor, and vanilla is a flavor on ice cream. Waffle cone is an ice cream, right? And what can we do that? We can even extend it like sprinkles on this ice cream. We can even put cherry on this ice cream, right? Do you see that? So all these gives you a recipe to make an ice cream. And just single sprinkle, single vanilla, or even vanilla on waffle cone. It's not an ice cream because we do not have a way to make an ice cream in this way.